Hello everyone, we are in our lesson continuing to study mechanics, and today our task is to study such a concept as work. What is this concept? When you and I perform a certain action, then naturally we have to spend certain resources for this action. For example, in order to rise from the first floor to the second or the third floor, we apply certain expenses of our resources. At the same time, we can be a little tired as we rise. And this is exactly the fulfillment of certain actions as the fulfillment of work to lift our body from one floor to another. When we talk about mechanical work, we are talking about the fact that a certain body can move through the actions of a certain force for a certain distance. And if these two factors coincide, then we can say that a certain mechanical work is being performed. So let's use an example to show what this situation looks like, because there can be many such cases, and depending on how the force acts in relation to the direction of movement, you can talk differently about the work being done. So in the first case, we can consider a situation where a certain force acts on a body. So we are talking about only one force, without stipulating that there are additional forces acting on this body. We are interested only in the action of this force, under the action of which the corresponding object moves. And there is a certain displacement that this body makes, which in this case coincides with the direction of the force. What then is the formula by which we can determine the work of a given force? The work is denoted by the letter W. And by definition, it is equal to the product of the given force by the displacement of the given body. In this case, we are talking about the scalar product of two vectors, the vector of the given force and the vector of displacement. Why should we talk about this particular situation? Because when we consider cases with the action of force at other angles in relation to displacement, this scalar product helps to understand how to calculate the correct work in this situation. According to this formula, we see that the work will be measured in newtons times a meter, and this unit of measurement is called joule. So if we further describe the unit of force in newtons, we remember that the newton is a kilogram multiplied by a meter and divided by a second squared. Then combining these two expressions, we get that a joule is a kilogram multiplied by a meter squared and divided by a second squared. In this case, if necessary, we will use either the ready unit of measurement joule, or if we need to bring all the units of measurement to the SI system, then we will use a record of the appropriate form. So now let's look a little more closely at the scalar product of force and displacement, and remember that we can write it through the moduli of the corresponding vectors and the angle between these vectors. As a result, we get a formula that will already help us to calculate the magnitude of this work. Given that we know three parameters, this is the force, this is the displacement, this is the angle between these two vectors. And to begin with, let's remember once again that the cosine of an angle can have different values. And depending on the angle, we can change the value of the corresponding work. So if we consider the case where the angle is greater than 0 or equal to 0 but less than 90 degrees, that is, the force in this case, for example, coincides with the movement of a given body, then the angle between them turns out to be 0, or forms some acute angle, then in this case the cosine will either be equal to 1, for example, or have some positive value. That is, in any of these options, the work will take on a positive value. And this is one of the situations that we may encounter while solving problems. Now, if the angle is 90 degrees, that is, the force acts perpendicularly to the displacement. So in particular here, for example, we can find exactly the force that acts perpendicularly to the displacement of this body. If a body is moving horizontally on a surface, we remember that, for example, there's a support force acting on the body, And then it will be clear that there will be an angle of 90 degrees between the displacement and this force if you and I draw it here. In this situation, the work of this force will be 0, because the body vertically is not moving anywhere. In this situation, we have to always look at this nuance, because in each problem, you may have a different question for a particular force. It is necessary to look carefully at the work of what force you are defining in this problem. And then the next case, if theta is greater than 19 degrees, is less than or equal to 180 degrees. That is, the angle between the force and the displacement is obtuse, and then we understand with you that the work will have a negative value. This can also happen, so in your answers you should look at the sign that the work has in this calculation. On a graph we can show you the relationship between the applied force and the displacement of a given object. Let's plot this relationship and show how the force behaves in this situation. If the force does not change, that is, remains constant in its value, then the value of this force when moving this body remains fixed, i.e. some value F. And for example, the body has moved by some displacement d. Then the work of moving this object is the product of force on displacement. We can see that we've ended up with a shape called a rectangle. And the product of its two sides gives us directly the area of the rectangle. Thus, you and I conclude that graphically the area of the figure under the graph of force will give us the value of the work performed by this force. Moreover, it will not depend on how this graph looks. That is, this graph may look completely arbitrary because we may encounter different situations in different tasks. For example, if you recall the value of the elastic force, that is, how it changes with deformation of a given object, then as the deformation increases, the elastic force will increase. Then in this case, the work will be determined by the product of the half sum of the initial and final values of this force, and this will end up being the area of a right triangle. If, for example, we have a value of force that varies nonlinearly with displacement, let's say we have some kind of a quadratic relationship, then that would be the area under this graph, and we must connect more complex mathematical calculations, but nevertheless the sense of work in this case will remain the same. Therefore, in the tasks, you and I must understand how this force behaves when moving this object, and if it is not possible to calculate this work analytically, then we can resort to the graphical method. This is also a very good method that helps to solve quite complex problems very often. With that, I'll say goodbye to you, and I'll see you in the next lessons, where we'll put these formulas into practice. Goodbye.